Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Y Combinator presents Ian Fischer, co-founder of Poetic, whose 7-person team recently topped the leaderboard for humanity's last exam, a benchmark designed to challenge even the most advanced AI models. They outperformed Anthropic's Claude Opus 4.6 without massive compute budgets or lengthy training cycles. Fischer's position: the standard practice of fine-tuning AI models amounts to burning capital with no lasting advantage. His company's success rests on a radically different architecture, one that treats models as engines rather than final products. Ian Fischer brings an unusual trajectory to AI research. His first Y Combinator startup, focused on cross-platform mobile development, was acquired by Google. He used that exit as a pivot point, redirecting his career toward machine learning and robotics. He spent roughly a decade as a researcher at Google and Google DeepMind before founding Poetic. His team consists entirely of research scientists and research engineers, numbering just 7 people total. Despite this minimal headcount, they've achieved state-of-the-art results on some of the world's most challenging AI benchmarks. Last week, Poetic's 7-person team achieved the top score on humanity's last exam, a benchmark specifically engineered to expose the limits of current AI systems. They surpassed Anthropic's Claude Opus 4.6, a model backed by vastly larger teams and budgets. The assumption would be that this required millions in compute spend and months of dedicated training. Fischer's claim that assumption is wrong. During the interview, the host pressed Fischer on this achievement. Poetic employs only 7 people, all research scientists and research engineers, yet they delivered state-of-the-art performance on one of the hardest AI benchmarks available, beating a team at Anthropic that operates at an entirely different scale. Fischer's first assertion challenges the dominant strategy in enterprise AI. Nearly every company building AI applications today assumes they must fine-tune generic models on proprietary data to make them useful for specific verticals. Fischer's position: fine-tuning is economically irrational, equivalent to incinerating capital. There's biographical context that lends credibility to Fischer's bold claims. Before entering AI, he founded a cross-platform mobile development startup that went through Y Combinator and was later acquired by Google. He used that acquisition as a transition point, shifting his focus entirely to AI and robotics. Following the acquisition, he spent approximately a decade as a machine learning researcher at Google and then Google DeepMind before co-founding Poetic. His economic argument draws from what he calls the bitter lesson in AI development. Companies invest months and hundreds of millions of dollars fine-tuning a model like GPT-3.5 for their specific use case. By the time the fine-tuned model is complete, a new frontier model such as GPT-4 or Gemini releases, and its baseline performance immediately exceeds the custom-tuned version. The startup that allocated its entire runway to fine-tuning now holds an obsolete asset. Fischer argues that embedding knowledge into model weights creates a static product in a field defined by rapid iteration. His alternative: construct a system that sits on top of the model, which he describes as a harness or stilts. When a superior model releases, the harness simply mounts onto it, extending its reach rather than being replaced. The host seized on this metaphor, joking that Poetic's approach gives startups stilts, allowing them to remain taller than whatever frontier model emerges. Fischer confirmed this interpretation, stating that their objective is to reach the performance ceiling of any model before competitors. Transitioning from economic strategy to engineering performance, Fischer presents data that inverts the standard cost-to-capability relationship. Industry consensus holds that superior reasoning requires exponentially more expensive compute. To achieve state-of-the-art intelligence, you must pay for the largest, most costly models. Fischer refutes this with empirical results from Poetic's experiments. He references their work on the ARC AGI 2 benchmark. Google's Gemini 3 DeepThink scored 45% at approximately $70 per problem. Fischer's system, using the less expensive Gemini 3 Pro model wrapped in their reasoning harness, scored 54% at $32 per problem. This represents nearly a 10-point performance gain at less than half the cost. A cheaper, smaller model, enclosed in a recursive reasoning architecture, outperformed a raw, expensive frontier model. He added that their optimization run for humanity's last exam cost under $100,000, a fraction of the training budgets for the models they defeated. This discussion led to a moment the host found personally relatable. He admitted that in his spare time, He engages in extensive context engineering and prompt stuffing, a manual and frustrating process familiar to anyone attempting to coax complex behavior from large language models. This frustration served as an entry point to Fischer's next claim. Fischer's position on prompt engineering contradicts the current industry focus. We are currently in an era where highly compensated specialists craft English instructions to optimize LLM outputs. Fischer suggests this entire discipline targets the wrong variable. He shares a case study where his team manually optimized prompts for an extremely difficult task using Gemini 1.5 Flash. After significant human effort, they achieved only a 5% success rate. When they stopped refining natural language prompts and instead implemented reasoning strategies, programmatic code structures, forcing the model to think recursively, performance jumped from 5% to 95%. This suggests the interface for advanced intelligence is not linguistic refinement, but software architecture. The semantic nuances humans obsess over are statistically negligible compared to the structural scaffolding of the query. Fischer's observation regarding data quality further disrupts conventional machine learning doctrine. The foundational rule in ML is absolute. Understand your data, clean your data, ensure your inputs are pristine. Feeding a model corrupted data produces corrupted outputs. Fischer shared a story that directly contradicts this principle. One of the examples Poetic's metasystem generated to assist with solving an ArcAG problem was factually incorrect. Rather than removing it, they intentionally left it in the dataset. As Fischer put it, they don't want to go in and monkey around with things. The counterintuitive result: the system performs better with some examples that appear erroneous to humans because the AI identifies reasoning triggers in the data that humans cannot perceive. Fischer's experience with their metasystem completely overturns data hygiene orthodoxy. Their system automatically generates prompts and examples to feed into the model. When Fischer reviews these machine-generated inputs, he encounters content no human would write. Some examples are overly simplistic, others are factually wrong. Intuition suggests that incorrect examples in the context window should induce hallucinations. Yet the system retains them because empirical data confirms they improve performance. The AI comprehends the latent space of the model more accurately than a human engineer can. What appears to be noise or error to a human functions as a high-signal reasoning trigger for the LLM. Fischer believes we have reached a threshold where humans should stop attempting to understand the data and allow the AI to optimize its own context, even when the result appears nonsensical. Fischer concludes with a redefinition of self-improvement that challenges AGI research assumptions. The standard interpretation of recursive self-improvement involves an AI rewriting its own source code or retraining its neural weights. Fischer argues this is unnecessary overhead. He proposes that increasing intelligence does not require altering the underlying biological brain the model weights. It requires improving the mind, the software processes operating on that brain. By constructing a system that recursively improves the reasoning harness, Poetic creates a self-improving loop that remains independent of any specific model. This redefines the path to superintelligence not as biological evolution of the model, but as technological evolution of the tool set the model employs. It treats the LLM not as the thinker, but as the engine, with intelligence emerging from the transmission system built around it. Fischer encapsulates this philosophy with a concept he calls being vaccinated against the bitter lesson. In a world where computing power scales relentlessly, the only work that retains value is work that scales with the hardware. By constructing reasoning structures instead of fine-tuned weights, he claims to have identified the sole strategy that compounds rather than depreciates when the next generation of AI arrives. This is not abstract theory for Fischer. His entire journey appears to have come full circle recently. He shared that last summer, he spent a weekend using a frontier AI model to help him build an iPhone app, something he hadn't done in a decade since his first startup. He was struck by how fast and accessible the process had become. It was a direct, personal experience of how the right AI tooling doesn't merely enhance productivity incrementally. It fundamentally transforms what a single person can build. If you're interested in the video featured in this episode, click the link below to watch the original.